This video is about solving for a missing value using proportions of similar figures and setting up a proportion from a real life situation. So remember that a similarity ratio is the ratio of the corresponding sides. So number one, we want to write a similarity statement, state why the triangles are similar, then solve for x and y and find the similarity ratio. So if we look at these triangles, we see that these two lines in the middle and at the bottom have arrows on them, which means they are parallel, which means that angle B is going to be congruent to angle A because they are corresponding angles. We also know that angle C is in both triangles because we have our little triangle and our larger triangle. Now that the two triangles have two congruent angles, we know that they are, now we know that the two triangles have two congruent angles, they are now similar. So we can say triangle BCD is similar to triangle ACE by angle-angle similarity. So now we want to solve for x and y. So to solve for x, we see that x is on this side. So this whole side here, when we add it together, is going to be x plus 16. That's going to correspond with the side that's 12. So we have 12 over x plus 16 equals, on the other side, we have 6 and the whole length is 14. So equals 6 over 14. So as we cross multiply here, we get 6 times x plus 16 equals 168. 6x plus 96 equals 168. We can subtract 96. 6x equals 72. When we divide, we get x is 12. Once we know x is 12, we can solve for y. So again, we can use 6 over 14. We're going to set it equal to y from the first triangle and 28 from the second triangle. So y over 28. So when we cross multiply, 14y equals 168. When we divide by 14, y is also 12. To get our similarity ratio, it is the ratio of the corresponding sides. So when we look at our similarity statement, that's going to help us set up the similarity ratio because we want the side from the first triangle over the side from the second triangle. So a side from the first triangle was 6, a side from the second triangle that's corresponding is 14. That reduces to a ratio of 3 over 7. In number 2, we again have parallel sides with A, B, and DE. So we can use alternate interior angles, say that angle A is congruent to angle E. We can also use vertical angles that are congruent. So we now have two sets of congruent angles in these triangles. So we can write a similarity statement. Triangle ABC is similar to triangle EDC by angle-angle similarity. So when we go to set up our ratio here, we have 2 and 6 are corresponding sides because they're on the same diagonal, and in the name, they are the second and third letter. So we're going to use 2 over 6 equals twice to solve for x and y. So to solve for x, we would have x plus 3 over 2x plus 13. So when we cross multiply, 2 times 2x plus 13 equals 6 times x plus 3. That gets us 4x plus 6 equals 6x plus 18. 4x plus 26, there we go. So when we subtract here, we would get 2x equals 8, divide, so x is 4. Then to find y, we would use 5 over 6y minus 9. So 2 over 6 equals 5 over 6y minus 9. So we cross multiply, 2 times 6y minus 9 is equal to 30. Distribute 12y minus 18 equals 30. We can subtract 18 from both sides. 12y equals 48. We divide, y is 4. To find the ratio of sides, We have 2 from the first triangle and 6 from the second triangle as the corresponding sides. That reduces to 1/3. In number 3, we have BL is parallel to EK. We know that B and E are congruent angles because they are alternate interior. We have our vertical angles are congruent. We now have 2 sets of angles congruent. So we can say triangle BLA is similar to triangle EKA by angle-angle similarity. So in this case, we're only solving for x. So in the first triangle, we have the side 9, which is going to match up with x minus 1. So we have 9 over x minus 1. The other side in the first triangle is x plus 8, which is going to match up with the side that is x. So when we cross multiply here, we get 9x equals x minus 1 times x plus 8. So we can distribute 9x equals x squared plus 8x minus 1x minus 8. 9x equals x squared plus 7x minus 8. We can subtract the 9x from both sides. So 0 equals x squared minus 2x minus 8. So we need two numbers that multiply to -8 and add to -2, x minus 4 and x plus 2. So x equals 4 and x equals -2. Now in this case, -2 is not going to work because if I have -2 minus 1, I get a negative side length. So x is only going to equal 4. When I substitute 4 in to the side with that corresponds with 9, 4 minus 1 is 3. So our ratio is 9 over 3, which reduces to 3 over 1. So in our next problem, we have ABC is similar to DEF. So we're going to draw two triangles here. So I have triangle ABC and triangle DEF. AB is 16, BC is 28, AC is 32, EF is 21, and we want to find DF. So I'm going to call that X. So we need to set up a ratio that uses the corresponding sides. So not all sides may be used in this problem. So if I look at the triangle that has two side lengths, 21 and 28 match up. So we have 28 over 21, and x and 32 match up. So 32 over x. So I did the first triangle over the second triangle. So when I cross multiply, I get 28x is equal to 672. When we divide, we get x is 24. In our next problem, James gave his dad a model pirate ship for his birthday. The ratio of the model to the actual size is 2 inches to 5 feet. If the model is 16 inches long, 6 inches wide, and 4 inches tall, how many feet long, wide, and tall is the actual pirate ship? So we have a ratio of 2 over 5. So we're going to use that 3 times for the length, the width, and the height. So we have 2 over 5, 2 over 5, and 2 over 5. The top of the ratio in each of these represents the model, which are the dimensions we were given. So to do the length, we would have a model of 16 over x. When we cross multiply, we get 2x equals 80. When we divide, we get x is 40 feet. For the width, we have the model as 6 inches over x. So we get 2x equals 30. When we divide, we get x is 15 feet for the width. And for the height, we have 2 over 5 equals 4 over x. When we cross multiply, 2x equals 20. So x is 10 feet. In our next problem, on a map, the distance between two towns is 15 inches. On the same map, 2.5 inches is 23 miles. So this is our ratio. So we have 2.5 over 23 equals what we measure on the map, which is 15 inches. We want to know how far apart are those actual towns. So when we cross multiply, we get 2.5x is equal to 3,000 or 300 and 45. When we divide, we get x equals 138 miles. A 6-foot pole casts a shadow that is 8 inches long. So when we have a 6-foot pole, the pole is going to be standing up. The shadow is going to be on the ground. How tall is an antenna that casts a 60-foot shadow? So we don't know the height of the antenna, but we know that the shadow is 60 feet. So when we go to set up a ratio, we want the ratio of the object together, and we want the ratio of the shadows together. So we get 6 over x is equal to 8 over 60. When we cross multiply here, we get 8x equals 360. When we divide by 8, x is 45 feet. In number 6, Jenny is 5 feet 6 inches tall. She is standing 4 feet from a lamppost. Her shadow is 7 feet 3 inches long. How tall is the lamppost? So we are going to have a lamppost and Jenny, and we can create a triangle here. So we don't know how tall the lamppost is, but there's a mix of inches and feet in here, so we're going to convert everything to inches. So if Jenny is 5 feet 6 inches, 5 feet, every foot is 12 inches, so 5 times 12 is 60, plus 6 gets us, she is 66 inches. She is 4 feet away from the lamppost, so 4 times 12 gets us 48 inches. And her shadow is 7 feet 3 inches. So 7 times 12 is 84, plus 3 gets us 87. So we want to find the ratio. We want to use the ratios to figure out how tall the lamppost is. So we have 2 triangles, one with Jenny and her shadow, and then one with the lamppost. So we know that Jenny is 66 inches tall, but we don't know how tall the lamppost is. We also know that Jenny's shadow is 87 inches, and the distance from the lamppost to the shadow. So we have to add up these 2 distances together to get 135. So when we cross multiply here, we get 87 equals 8,910, 87x. So when we divide, we get x is about 102.41 inches. In number 10, find x in the 2 parts of the base. Round your answer to the nearest hundredth at the end of the problem if necessary. So we know right now that we have 2 triangles. We have x in the middle where the lines of those 2 triangles are crossing. We also know that the whole base of the triangle is 60, but we don't know what each part is. So I'm going to call the first part y, which makes the second part y minus 60. So we really have 2 problems here. We have a smaller triangle, and we have the larger triangle. So if we label each triangle the smaller triangle, we have 25y, 60 minus y, and x. And then in the bigger triangle, we have x, 75, y, 60 minus y. So if we look at our triangle here, we have a smaller triangle inside the larger triangle with the 25. So we would have x over 25 equals, and the part of the triangle here is going to be 60 minus y over the whole length of that side, which we already know is 60. So when we cross multiply here, we get 60x equals 25 times 60 minus y, which gets us 60x equals 1,500 minus 25y. And I'm going to stop. Then I look at the other problem. We have x over 75 equals y over the whole side length, which is 60. So we get 60x equals 75y. Now, because they are both equal to 60x, we can set them equal to find y. So we're going to use substitution. We are going to set 1,500 minus 25y equals 75x. So we get 1,500 equals 100y. When we divide, y is 15. So we know the base lengths are 15 and then 60 minus 15, which is 45. To get x then, we need to substitute back in. So we now know y is 15. So I'm going to use this equation, 60x equals 75 times 15. 60x equals 1,125. When we divide, x is 18.75.